All right, so a recap on what just happened because the video crashed. Basically what we did was we created a box using box2point, okay? And then we used the empty housings for params here, from params to reference these points in the Rhino user interface. We generated the points in Rhino, we set them into the Grasshopper interface, and then we generated the box. But if I want to generate those points exclusively in Grasshopper, and there are a lot of reasons you might want to do this in some cases, it looks a little bit differently, right? So if I want to do it numerically using Grasshopper, and then I can change the sliders, I can do it this way. So let's get rid of these points here. So if you click and drag a box like any of the other software packages I think you all mentioned you can just select them all that way and hit the delete button, and that'll get rid of them. Okay, so go ahead and do that. You can also go into Rhino and delete these points. They're not going to be used anymore, so go ahead and drag a box around those and delete them. And just a real quick preface, I didn't go over the orbiting in perspective. I think it's important to quickly go back to that for those of you who are less familiar with Rhino. If you left click in the space, you're either going to select or drag a box somewhere. But if you right click, it's going to do an orbit. And if you hold shift and right click, it's going to pan. And then obviously your scroll wheel is going to go in and out. I think that's pretty standard across the board for most software packages. So also the thing, well, don't worry about that one. Okay, so let's move on to the actual point thing. So this is where Grasshopper actually starts to get pretty powerful, because the information that you generate for one geometry can be used to generate other geometries, right? So if I happen to want to create a box that is 5 by 5 by 5, and then create another box that's exactly half of that, then I can use smart math within the Grasshopper user interface in order to generate that. So if I go to the Vector tab and the Point panel, we can use this tool that's called Construct Point. Now when you drop it into the space, actually one of the things I want to just kind of mention to you is a bit of a learning management feature that I do. So I like to make sure that you know where these tools come from. So when I drop in a bunch of tools, I typically tag them with a little label that shows you where it came from. So for instance, this box tool came from Surface and Primitive. So I'll usually group it with one of those boxes. I select it and hit Control-G. And it creates this little purple box around it. If I did it around both, it would create a group around both objects. But I like to do it on each individual object so that I can name them. And I name them by right-clicking on the box and going to this little text selection here. And I call it SRF and then P surface prim, like that. And so that way it just gives you a visual cue that says where it came from. The reason I do that is because it helped me tremendously the first couple of times that I was building a Grasshopper definition to just have it there, because then I can see relationships. So if I see a string of surface items, or if I see a surface followed by a bunch of surface analysis ones, it's a different kind of thing. So anyway, so that came from Surface and Primitive, and the point came from Vector and Point. Vector, Point. So this one comes preloaded. What it's going to ask for, it constructs a point from the X, Y, and Z coordinates. And then you can see that the output side is that it basically just generates a point. On the input side, it's asking for the X coordinate, the Y coordinate, and the Z coordinate. But what you should be aware of is this right here. So I mentioned with the point params, it said that it needs a point parameter. this one has a number. It's telling you that it needs a numerical input. You don't put a point input into the y coordinate because it's a numerical position. So anyway, we can do that using sliders, which is basically you can kind of go back and forth, or we can just put a number in it. To keep things kind of parametric and malleable for you, I tend to default to sliders first, and then I start to introduce static numbers later on. So to create a slider, you can either go to the Param tab under the Input panel, and you can click Number Slider. And it drops it in like this, and it kind of gives you a bunch of default settings. But I'm going to go into excruciating detail here about shortcutting your number sliders. So if you want to make a number slider and define a lot of those features directly, the first time you drop it in, double click, and there's some syntax that you can put in to create a quick specific number slider. So some of you saw that when I made the slider in the preface that I did 1 less than 10. That created a number slider with a minimum of, or 0 less than 10, whatever it was, with a minimum of 0 and a maximum of 10. But because I typed in those numbers as whole numbers, then I got a whole numbers slider. I could go from 0 to 1 to 2 to 3 to 4, and I couldn't do any numbers in between. I couldn't do a decimal point. So what you have to do to get that is to say 0 is less than 10.00, and that'll make it a slider that goes to 2 decimal places. You hit enter, and you see that it starts at 0, and it goes up to 10 at a decimal point like that. Now, if I wanted it to, what was I just going to introduce? Maybe I'll come back to that. Anyway, this is going to serve our purpose for right now. I don't want to confuse you with too much detail right now. So I'm going to need an x coordinate, a y coordinate, and a z coordinate. So I can basically, what I want to do here is put my x, y, and z set to 0. And so I can just kind of pull it all the way back and make 3 copies. So Control C, Control V is what I do to, it's just the typical hotkey. And I make 3 of these, and then plug it into the X, the Y, and the Z. And now what you're going to find is that the point has been created at the origin of 0. Okay, so if I make, or if I move my slider in the X direction, you see that it's now sliding outward. Right, you guys can see that on screen? All right, so now we've pretty much got a whole slider set up for the origin. I can just copy that whole block down in order to make my second point for the other side of the box. So I can select this whole thing, copy and paste, and you'll see that it kind of places the whole construct right there. I'll just pull it down like this, and then I can make my next one. Are you guys keeping up? Do I need to pause for a moment while you get caught up? Give me a head nod. The individual item? Sure. Yeah, so any component you bring in, I'll just bring in one of these. Grouping, you just select it by clicking it, and then hit Control G, and it makes this little purple box around it. And then you can right-click it to name it if you want to name it, and go into this little box here.
Are the commands often the same as Rhino?
The commands in Grasshopper,
Yeah.
do they mirror the commands in Rhino? In most cases, but not all. All right, so I'm going to pause for a moment and just kind of come around, verify that you guys are caught up, clear up any troubleshooting before we continue on.
For the slide.
So the question was, how do you make it a negative slider? If I want to do a negative slider, I can say start off with the negative because it reads left to right, right? It's basically a mathematical formula. So you start off with negative 10, then you go up to 0. But if you want to start at 0 and you want to maybe go back to negative 10 or up to positive 10, then you're going to start at negative 10. You're going to begin with negative 10. Then you're going to put a number for your starting point, and then you're going to do another less than for 10. So that basically, this is like the next level of detail that you can give it. You can do a slider from negative 10 to 10, and you want to start your slider at 0. So if I hit enter on that, then I can go down to negative 10 or up to 10. Okay, just throwing that to you.
Thank you.
Yep. So I'm resuming on in the same video here for you guys real fast. But I just wanted to there was something I was going to do and then I lost it. It was another side point. Anyway, but I do want to point out here that you have a way of figuring out which geometry is what in space by clicking on that component. So notice how when I click on box and box shows up green here, notice how here in the Rhino user interface that little frame shows up green as well. So basically what that's telling you is when I select something in the Grasshopper user interface, it shows me where that is in the Rhino user interface. Okay, so that's very important to know. So the reason I mention that is because we have a point here and we have a point here. That point shows up green here right now, and if I click the other one, it doesn't really show up at all. It's getting down into the nitty-gritty, but basically it's because they're on top of one another. So I need to move this point to another location. That other location, I want it to be in the same position as the box that I just generated. So that's going to be a value of 5 in the x direction, 5 in the y direction, 5 in the z direction. So I can do that by changing all these sliders to 5. So you can slide it all the way up, but be aware that you might not be able to get exactly 5. I did here because it's moving in tenths, but you might not be able to. So the quick shortcut way is to double click that number and it'll automatically jump to, if you type in 5, it'll jump to 5. So notice how that point now moved 5 points in the x direction to this corner. And if I change the next value to 5 and spin it around, that point now exists at 5, 5. And then if I change the third and final one to 5, you see it jumps up to the opposite corner here. So now our points are in their proper locations. We can make the connection from the points themselves to the box generation tool. So all that's going to do, you don't have to worry about P because P is just saying it's going to happen here in this location. But A is going to be your first point, and you can make the connection here. And then B is going to be your second point, and that's going to be this connection right there. And notice how now it turned gray. If I select it, it created a box here. If I go into Rhino and I delete that box, then it's just a Grasshopper generated box that's 5 points, 5 units large. So, how do I make this more efficient? I'm going to pose that question to you guys often throughout the semester. I did something that's a little bit redundant. What do you think that might be?
Well, you made the same thing twice. You copy pasted the x, y, and z coordinates twice.
The sliders? Yeah, exactly. Yeah, I copy and pasted them 3 times for every single coordinate. However, they're all the same value. So do I really need all 3 of those sliders? The answer is no. The cool thing about these outputs is that you can output something as many times as you want. There's no limit on how many connections you can make from a particular item. So if I only wanted, if I knew that this was going to be exactly a box, or exactly, if it was going to be a box that had the same magnitude on every side at all times, all I'd have to do is just set a common beginning point. So 0, 0, 0 is going to be fine. And I can just drag it out to the Y, the Z, make the connection. And I can do the same thing for the opposite corner. 5, 5, and 5. So now as I slide this box in and out, it's going to stay a perfect cube. But it's going to go anywhere from 0 to 10 in size. Yes?
Forms that you create on Grasshopper, can you manipulate them in Rhino? Because like I noticed that when I switch to kind of Rhino, it seems like it's locked.
It's a very good question. Can you manipulate these forms on the Rhino side? I will answer it in another video. In fact, the next video. But this one's getting quite long and I want to... Yeah. Any other questions about this specifically or no? Okay. Let's move on to your question.